Hello, good afternoon. I am so happy to see you on this chilly February, but it's Tennessee, so the daffodils are in bloom and it's 20 degrees, so it's a regular February in Tennessee. I'm just a couple of announcements before we get started. Last week, you may have picked up one of your optional Beyond the Classroom experiences, Dr. Janet Pulaski, for the Strickland Lecture. And right after I told you about this, she tripped, fell, broke her ankle and her wrist, and this will be in the fall. So this will no longer be an option for your Beyond the Classroom experience this semester, but we have lots of others, right? We have a concert, we have other speakers, including by the door, Carol Humphreys talking about the revolutionary press, the role of the press. And where are we going to be on the Monday after spring break? Todd, 350, printing our copies of the Declaration of Independence. Yes?
Was that event you were talking about the one that was also on the 16th?
This was scheduled for the 23rd, the next week. So again, fortunately, we have lots of options for that. Also, remember what civic engagement activity is happening at 6 o'clock today in the Student Union Building atrium? Yes, so the candidates for key offices in the Student Government Association are debating and presenting their positions. And how many of you are going to vote in the SGA election? Wrong answer. How many of you are voting in the SGA election? Okay, I can't vote. You have to vote for me, right? I'm not a student any longer, just a student of life. Okay, so that's at 6 o'clock today. Today, this afternoon, we had the great pleasure to have Dr. Scott Handy, one of my longtime colleagues, to give today's lecture. Dr. Handy got his PhD in chemistry from Indiana University in 1996. He then had a postdoctoral research fellowship from the National Institutes of Health at Stanford University before coming to MTSU. He is an expert in researches organic synthesis, and he has been recognized for his teaching and his research. He won the MTSU Distinguished Research Award in fall of 2010. He's also won awards from his college and has been recognized by student organizations. He also worked for a while as the Associate Dean in the College of Graduate Studies. He is a Renaissance man who was one of the only folks willing to tackle the Age of Revolution science in the 1700s for me to mark this semi-quincentennial year. So I'm very thankful and happy to introduce Scott Handy.
Well, thank you very much for that introduction. I'm not sure whether it's brave enough or foolish enough to take this on, but if it gives me a chance to learn about something and then try to convey that, I'm on board. So before I launch into all of this, a couple of kind of upfront disclaimers. Actually, I'll make it three. The first disclaimer is to historians out there, I apologize. Yes, I kind of redefine eras a little bit to suit a scientist's needs. So yeah, some of the dates may not perfectly mesh, but that's my prerogative. Also, I want to, particularly early on, there may be some aspects of this where I sound like, oh my gosh, he just is so anti-religion. No. Indeed, lifelong Lutheran here, so definitely not anti-religious. But we will see as we talk about this, there were certain aspects of religion and religious uniformity that were definitely inhibitors. So that's more my point is we have to watch out about how definitive we are in knowing everything. And honestly, that holds true for all of us. Lastly, although I have already apologized to Dr. McRae, I'll apologize to all of the rest of you. There are a bunch of French names. I am not good at pronouncing French, so they will be questionable, but I'll try to say them at least with confidence. So, with that perhaps terrifying introduction, let's launch into talking about science, particularly in the 1700s, and I would say science since the 1700s. Again, the key point, so if I had to do this as a tweet or an X, is the major shift that underlies everything else I'm going to talk about is this flow from kind of source to knowledge. And yes, I have no artistic ability, so there we've seen it. And what could we reliably use as a source for gaining knowledge? That was the remarkable shift that occurred really predominantly in that 100-year period of the 1700s. And it's a shift that hopefully through this we'll come to see or come to accept, wow, that was really amazing. So in order to appreciate how amazing this shift is, we need to know where are we coming from. If we don't know that, there's nothing amazing. So setting the stage for this shift, prior to and kind of leading up to, honestly, the 1700s, there really was this idea that the authoritative source of all knowledge was the church, and by the church, the Roman Catholic Church, the papacy in Rome, and then the Holy Scriptures. That if we were going to explain anything, if we were going to understand anything, it had to come in the context of the tradition of the church or the Holy Scriptures. That was it. If it didn't agree with that, this is not acceptable. The result was that there were some things that certainly there were many learned people who knew this is not true, but you didn't dare say it publicly. The idea of the earth being flat, no. But where that ran contrary to church dogma, you disagree with that at tremendous peril. Certainly we currently have examples of that as well, where you disagree with something to your own peril, and indeed all periods in time of life have had that. So prior to, this had been very strongly ingrained that we need to keep this in mind and don't dare venture too far. Now, I should also say that when I'm talking about this, I'm of course talking about Western history, so I'm focusing on Europe, the European colonies, which, the United States, well, pre-United States was definitely part of that. But fortunately, there'd been some first steps towards overcoming this. And the first thing was definitely the Reformation, this erosion of uniformity of religious belief. We had individuals, Martin Luther, John Calvin, John Huss, and a host of others who started to question, really? The Pope is infallible? tradition is the same thing? No. We need to take a step back on some of this. And so that infallibility had started to fracture. Now, more so in some places than in others. And indeed, I think you'll note as we move along that much of this scientific revolution is located in the northern half of Europe, as well as France, which has always been a little bit of an outlier, at least to me, in European history. Makes it interesting. But something had to fill this gap, and initially a lot of this gap was filled by the idea of divine right monarchs. So there's still a religious undertone, but now we have people exemplified here by Louis XIV and Henry VIII, where they're claiming the right and authority of, really, I am the ultimate determiner of everything. Now, fortunately, guess at least if you're a scientist, they didn't really care what scientists did. As long as you don't challenge their power, go explore whatever you want. So that helped to kind of further erode this idea that there are things we can explore and things that we can't explore. Following up on that, though, we then hit the Enlightenment time period. And the Enlightenment, at least to me, continues on really throughout the 1700s. And here's where we see this shift. We see this shift where we don't have to use religion. We don't have to use the divine as our source for explaining everything. Really, we can just look around at the world around us and we can say, what do I see there? What does that mean? Why do I think that happens? And we can use our own observations and our own tests and kind of experimenting, playing around with things to decide, do I understand that? Or, I still haven't figured that out. But much more flexibility in terms of how can we explain things and where can our understanding come from? It does not have to come from the divine. We can play a role in here as well. This is not to say that the divine goes away. A tremendous number of the people I'm going to talk about were very deeply religious, but that wasn't the only source of their answers. So that shift in and of itself is a monumental one, and I'll come back to that and try to highlight and point it out more as I go along. But if that was it, probably wouldn't have accomplished much in this time period. Coupling with that, though, were a number of additional shifts and changes and steps forward, at least in my opinion, that enabled an explosion throughout this 100 years. And definitely the first of these, which I have labeled under infrastructure, yeah, there's a scientist for you, infrastructure, was the idea of knowledge, getting our hands on knowledge. And they're encyclopedias. Nowadays, well, honestly, a lot of you are probably going, encyclopedias? Is that a typo? You're talking about Wikipedia, right? Well, yes, that's the current one. But no, I'm talking about print volumes, the good old classic encyclopedias. We have, of course, probably the most famous encyclopedist of all, Denis Diderot. Not the only one. But it became very popular, this idea of let's find all the knowledge that we can get and try to organize it and put it into these finite-sized compendium. That was critical because of something else that, honestly, nowadays probably doesn't make any sense. But in that time period, a person who had a library of 100 books would have been unbelievably wealthy. 100 books. I have more than 100 books in my faculty office. We're not going into how many books I have at home because I have no idea, but it's a lot. You had to be unbelievably wealthy to have access to that many books. And of course, that many books isn't really a lot if you're thinking about you want to have this great, tremendous scope of information that you can use to try to answer new questions. Well, the encyclopedists were working at, okay, can we fix this? Can we summarize this? Can we get more readily available summaries of information where now you don't need to have 100 books. You can get a 4 or 5 volume set. And of course, in the great tradition of good capitalists, we'll publish a new updated version of it in 2 years. So you've got to buy the new one. But some things never change. But this was a tremendous shift. And coupled with that shift, and part of the reason why I have 3 different sets here, are that these encyclopedias began to appear in the common language of that country. No longer was a knowledge of, not just a working knowledge, a great deep knowledge of Latin an essential requirement of even thinking about doing science. Instead, French, here, the Middle Encyclopedia Britannica for Great Britain, where, no, I don't have a name associated with that because, interestingly enough, no one's quite certain who started the Encyclopedia Britannica. Bunch of different people get credit for that. And then on the far side, for Germany, particularly Brockhaus, one of the earlier encyclopedists. But each one of these countries had numbers of people forming these and in the language of that country. So information far more readily available to a much broader set of society. Now, this is not to say that it was everyone. No, we are not that egalitarian. Still, this was for people who had sufficient means that they had the time and the opportunity to read these things, to think about something other than, where's my next meal coming from? But that was a more significant portion of society in the 1700s than it had been really leading into this time period. So, okay, we've got information. Another shift, and this is one maybe I'm not supposed to talk about at a university, but I will, was the rise of public societies. Leading into this time period, really, if you were going to talk about knowledge, information of any sort, it was going to be at a university. But the histories of all of those universities were really as theological entities. They were religiously founded and religiously connected, and they were conservative. They didn't want to shift and keep up with the times. In that aspect, universities, okay, yep, very familiar. We're, even though people like to say we're liberal, we're kind of conservative. We like the way we've been, and thus always should be. And this was what a role that public societies could fill. They could be less conservative, less stuck in what was the past, and more adapting to what was in the present. Universities still remained, and they were still very important, but many people from either this time period or a bit before it had actually left universities because they found that environment too stifling for their creativity. People who we probably have all heard of, Galileo, Descartes, Copernicus. Yeah, they gave up because a university was just not going to adapt to what they were thinking and what they saw in the world around them. So these public societies were a combination. Many of them were royally sponsored because, of course, they needed money. Money is important. And so you had the Académie Royale des Sciences in France, and you had Britain's Royal Society, also definitely royally sponsored. But increasingly, there were a handful of private societies. The American Philosophical Society, of course, had to throw in one from the Americas, and the Lunar Society, which points out a second point that I'll come back to in a few moments. And these were places where people who had interests in science, very broadly defined, could come, study, discuss, exchange information, and try to push things forward. Along kind of that same line of information, this is the time period when we finally see the first true periodicals. Before, there had been things that were called periodicals. I think they should be called sporadicals, because maybe there would be a volume every 5 years, or it might be 7, or maybe it would be 8, because, well, we just don't have enough to justify publishing something yet. At this time period, though, we see the first honest-to-goodness annuals, quarterlies, even a few monthlies, where you knew this was going to come out, and it was going to contain all of the new information from either a particular organization or about a particular topic gathered together in a very reliable, consistent fashion. Some of these continued on for ages. The Philosophical Transactions of the Royal Society, which goes definitely back before 1700, but operated for ages and eventually broke into several different journals that continue to this day. So they can trace their history back quite a ways. The Journal des Sçavans in France has gone through various permutations, but was also really technically the first annual, barely, over the British. So the French beat them there. And then we have things like the Journal for de Botanique, which illustrates another interesting point, that those first two journals, very broadly defined. They had science, they had philosophy, you could even throw in a little bit of theology in there. Information was fair game. But we started to get specialized journals, ones that were going to focus on just a particular area. This last one, you can probably guess, botany, and that was it. We're just going to talk about botany, nothing else. We're going to specialize and focus. So, more information. But there were also the kind of less formal aspects of information, and that is science fundamentally was popular at that point in time. The people who were making some of the biggest accomplishments, doing some of the grandest experiments, they could fill the largest halls that were available at the time. They could fill halls with hundreds, thousands of people. Believe it or not, they were kind of the Taylor Swifts of their day. They could sell out any place they wanted. And this was a popular activity for all of the public. And the results of these kind of after the fact, yes, we'd go to tea rooms if you happen to be in the British Isles, pubs, pretty much anywhere else, and also the British Isles, and discuss, well, what do you think of that? What was going on? What does that mean? What could we do with that? Really fundamental questions. And it was for anyone who could pay admission, which was definitely not thousands of dollars. Although, inflation adjusted, it still probably wasn't cheap. But it was popular, and it was something that was on everyone's mind. Another shift that occurred, so I'm shifting gears here, that happened during this time period was the rise of disciplines, the rise of, we're not going to try to be universal and figure out everything. We're going to focus on something and really understand a particular area. As a result, this time period shows kind of a very interesting mix of individuals who were hyper-focused on becoming true experts in one area in a fashion that's familiar to those of us who are faculty members where, yes, okay, we get a broad education, we focus that education, we focus within that focus and become incredible experts on something that's this wide, but that deep in terms of our knowledge. There are those, but there still are holdovers from before of more, and thank you for using that term Renaissance man, because who were Renaissance individuals? They wanted to know a little bit about everything, and so they did. It was still a time period where that was indeed not only acceptable, but to a great extent expected. But that shifted and shifted during this time period. So starting with chemistry, I'm a chemist, so yes, I have to start with chemistry. Chemistry, nobody even had the name chemistry before the 1700s. Instead, people thought about alchemy, about, okay, we've got this lead thing, we like gold more, so there must be some mystical, magical way we can do this. We don't know how, but we're certain we can find a formula to do that. That was the state of, quote, chemistry, not chemistry. The other thing that was very prominent up to this point was phlogistonism, which I will try to describe, but honestly, it is so strange to me, so foreign to me, that I won't do a very great job at describing it, but I'll try. There's this idea, though, that in everything was this fire element. Everything was made up of the fire element. And things like wood that burned really well had lots of the fire element in it. And things that didn't burn very well, like water, didn't have much fire element. Again, how could they at this time period have known what made up matter? They couldn't. They couldn't see anything that small. So they're trying to describe on the basis of, hey, this burns, this doesn't. How can I explain it? So phlogistonism, major dominant theory that was debated really through this entire century. You had individuals such as the first person I have up here, Joseph Priestley, who was a very heavy supporter of phlogistonism, remained so to the very end of his life, indeed so much so to the point that he got in trouble in Britain and had to flee to the colonies. But while he was a supporter of that theory that by the end of the century was pretty much gone, made some very significant discoveries. He discovered gases, which if you think about it for a moment, how on earth would you discover and identify a gas? You can't see it. You can't touch it. Yes, it's all around you, but ooh, talk about a challenge. And so he may have supported something that was discredited, but wow, what an accomplishment. He was the discoverer of oxygen, ammonia, carbon monoxide, and a number of other gases. I ran out of interest in listing all of them. But as a supporter of phlogistonism, he decided, I'm going to term these as different types of air, and I'm going to use air as kind of my synonym for fire elements. And so, of course, as you might guess, oxygen became the pure fire element. And again, interesting theories. On the other side of this was the French chemist Lavoisier, who, wow, did so much. We are still so indebted to Lavoisier. His counter theory was actually oxygen theory. And while we've gotten more sophisticated than that over time, we still use oxygen theory to explain a lot. Among the many accomplishments of Lavoisier, oxygen theory being one, another one that we still teach everybody, don't throw his name with it, sadly, is the idea of conservation of matter. Lavoisier demonstrated that if I take iron and I take oxygen and I react these two things together, that I wind up with something that's new, iron oxide, but it is iron and it is oxygen in a particular ratio. Importantly, he also demonstrated you could take iron oxide and get back to iron and oxygen, so the iron and the oxygen weren't somehow transformed into a new element. They were turned into a different form, but they were still iron and oxygen, just somehow connected differently. That somehow question, the answer to that had to wait for a different century, but a tremendous start. I'm working with Lavoisier on much of this, Morvieux, who did additional work supporting oxygen theory, but also developed a lot of the ways of how on earth are we going to name compounds, as opposed to going, okay, well, I'm going to call this one Fred and this one's George. No, let's give these a systematic name so that we have an idea what's in there. And it was based upon the elements that went into making that compound. So it was something that would make sense. John Dalton, down here at the bottom, also did some really, really interesting things. Atomic theory, and while we try to pretend that in high school and even in general chemistry at college that we're talking about more sophisticated theories, the Bohr and the Rutherford theories, really as far as how students come out of those classes thinking, it's actually still much more like Dalton's theory of the atom. The idea of atoms as balls, that we have this sphere of something that's carbon or copper or iron, whatever it happens to be. That all goes back to Dalton before anyone could possibly see or have an idea of what went into an atom, or even that there was an atom. This was his idea. John Dalton was also instrumental in coming up with those abbreviations for the different elements, which, depending upon what you've had to do with them, you may either remember with tremendous, oh gosh, I had to memorize all those, or maybe you're going, oh yeah, I got to do that. But the idea that we don't need a whole word for everything, we can just use one or two letters to abbreviate every last one of the elements. So chemistry got its start during this century, and from there it just took off and continues. Biology also got its start. Now, in a different sense, there was certainly no idea of molecular biology because chemists were still trying to figure out molecules. So, but on the bigger scale, biology and particularly botany saw a tremendous explosion, and much like with chemistry, saw a conflict during this time period between two schools of thought. One school of thought, exemplified by Carl von Linné, or Linnaeus, was this idea that we can take all of nature and we can organize it. we can put it into nice categories so that we can say, oh, these two things are more similar than these two things, and just nature can be organized so we can explain it. We can kind of file cabinet it. And so this idea of kingdoms, classes, phylums, orders, genus, species, all of that goes back to this time period. Now, the exact details of how do we categorize that has changed, because at this point in time it's basically built off of what can you see either with your eyes or with a modest microscope. So definitely none of the genetic patterns that we use nowadays, but a nice way to organize something that otherwise was just a random and lengthy list of names. On the other hand of the, or other side of this, we have the Comte de Buffon, who said, no way. There's no way that nature can possibly be organized. Nature is just what it is, how it was created, how it's seen. And so why would we ever try to use any of these organizational tools? Which I find interesting because he was enormously important in actually discovering and naming and describing a wide range of plant materials, and also very important in establishing some of the earliest public gardens in France, something that then caught on and went all over Europe. But as he was cataloging things, he took great care to try to organize similar things together in his catalog of plants. So he may have been opposed to the idea that there was an organizational method, definitely not opposed to organization. All right, so another discipline that arose during this time period, and one that we hear about all the time nowadays, statistics. Statistics had not been a thing prior to the 1700s, but was established. The father, if you will, Pierre-Simon de Laplace, who determined this idea of probability in statistics, and particularly introduced the idea of we can use sampling, random sampling, to predict the results of a larger area. Now, I'd love to be able to say that this was done for truly great humanitarian purposes. Actually, it was done at the request of the French government because they wanted to figure out how can we optimize tax revenue. And no, I'm not making this up. How can we optimize tax revenue? How can we take a look at the different regions in France and how can we decide, okay, what would be the appropriate population density here? Where do we have room to grow? Where are we maybe underutilizing resources? How can we optimize this so we can get the most money to support, probably most of the time, the wars that France was involved in during the time period? War is expensive, always has been, always will be. So regardless of the origin of why does somebody want this, statistics was founded during this time period and grew into applications in other areas where we can use these same ideas to try to study and explain and predict what might happen if we did something. Looking back at just mathematics itself, mathematics was very well established leading into the 1700s, and yet the 1700s witnessed, I don't know, as someone who actually did enjoy math a whole lot, it's hard to pick who is the most impressive mathematician of all time, because there are a lot of them. But I think Leonhard Euler definitely has to be in consideration for most impressive mathematician of all time. his accomplishments over much of this century were incredible. He introduced the idea of graph theory. He took Newton's laws of motion, and yes, we're going to hear about Newton in just a couple moments, and took them from a form that was kind of usable but didn't really apply the most recent math, particularly calculus, to it, and he reformulated them with full differential and integral calculus all worked in there to help explain how can you use this, how does it work. He also introduced a whole lot of modern symbols that we still use in math classes. There's Euler's number, E, for natural logarithms, I for imaginary numbers, pi, that was Euler's development, was we don't need to write the whole number out because we can't ever get to the end anyway. Let's just use pi. And in a controversy that isn't strictly math, probably I should have worked in with the physics section, there was this idea of what is light? What is light? With Newton being very, very strongly on the side of light is made up of corpuscles, things that we can't see because they're too small, but light is matter. It is 100% matter. Euler was on the opposite side, going, no. Light is waves. Waves, absolutely. You can't explain light if it's matter because it behaves like waves. Now, as we know now, although please don't ask me to explain how, because I'm a chemist, I'm not a physicist, that light is both matter and waves. It has characteristics and elements of both at the same time. Okay, yeah, that's where I stop because my head starts hurting. But Euler, tremendous accomplishments. Now, since I have mentioned him, I have to lead on into Sir Isaac Newton, who, although a lot of his work predates this time period, if you look at his dates, he made it into the 1700s, but not that long into it. The founder of classical physics, very instrumental in classical mechanics, contributions to optics, the nature of the solar system with the heliocentric model, and explaining why on earth would things orbit and how could they orbit. Unbelievable accomplishments, and much of the 1700s really in physics and astronomy was spent trying to catch up with what he'd done, because what he did was so incredible and paradigm shifting. Interestingly, kind of more in the time period where we're talking about, Isaac Newton shifted from physics to really deciding what was his true calling, theology. Yeah, if you're going, I haven't really heard much about the theology of Isaac Newton, there's a reason. He was not a great theologian. Indeed, it's a good thing he was so famous for his physics, because otherwise he probably would have joined Priestley in getting kicked out of Great Britain. But Isaac Newton, at the end of his life, was honestly more proud of his theology than all of his accomplishments for physics. We remember him for his physics. Medicine. And don't worry, this is not going to continue on for forever. I really have a finite number of slides. But I cannot leave out medicine, because in terms of true impact on daily life, everything I've talked about, I think honestly pales compared to the work of Edward Jenner. The development of the first vaccine, the smallpox vaccine. This was an accomplishment that I don't think we have any way of appreciating today. Smallpox was a terrifying scourge at the time. 10 to 20% mortality rate, and this was across the board. This was even for people who were very, very healthy and should be able to make it through things. No, still, 10 to 20% mortality rate. Highly contagious. If any member of a family caught smallpox, the rest was basically just waiting, oh, when am I going down? And even if you did not die, survivors, highly scarred. It's maybe a little hard to see, but this is a picture of someone with tremendous facial scarring from smallpox. It also impacted all other kinds of other parts of the anatomy. It could result in sterilization, just devastating disease. And what Jenner and others, but Jenner was a primary motivator in this, had noted was that milkmaids, so young women, girls who worked around cows, generally did not come down with smallpox. Now, they did catch something else. They caught cowpox, but cowpox was a very mild condition. It would resolve itself. It would go away. Fatalities? No. So there was this question of, well, does cowpox prevent smallpox? Are they related at all? What's going on here? And so in some experiments that absolutely nowadays there is zero chance of these being allowed, zero chance. It's, okay, let's take and let's infect someone with cowpox, make certain that they get cowpox, then let's go and intentionally, seriously infect them with smallpox and see what happens. And the answer was, they don't get smallpox. They just don't. And you can try it again. They still don't get smallpox. And thus, the first vaccine was developed. And the initial vaccines were, yes, they would gather cowpox, and infect people with cowpox to prevent them from getting smallpox. It was remarkably effective.
So with his manner of inoculation, was that the method of like where they cut skin open and
Yes.
add in tissue, or was it the one where they blow up their nose?
Initially, it was where they would cut. So it was, yes, directly through cuts. Amazing. And the fact that it did take a little time to actually be accepted, but as it did, it spread fast because of how genuinely horrible smallpox was and how feared it was. So I have a few slides here, kind of the applied sciences. There were a number of really fascinating things that came out during this century. The battery, we've got the first telegraphs. Those were mostly flag-based post-to-post. The seed drill, which fundamentally we still use in large-scale agriculture to this day. Looks a little fancier, same idea. Steam engine, varying permutations of that. The cotton gin, one of my favorites, the flush toilet, actually dates back to this time period. It's been refined a little since then. The piano, I love the piano. I play the piano, so had to put that in here. And Benjamin Franklin, because we definitely can't leave Benjamin Franklin out of a talk in the 1700s, with bifocals. Yes, that's what these are, but progressives. And lightning rods, just impressive. And this is but a small taste of the kinds of things that came about during this century as it's, wow, we're allowed to actually think and explore and observe and try to take that all in. Now, that's great. This is all amazing. At least I think it's pretty amazing. And it's something that really has continued to this day. I think that for as impressive as we think we are, and I'm not saying we're not, but for as smart as we think we are, creative as we think we are, these wonderful new discoveries, oh my gosh, we are just so brilliant. I don't know, maybe in a way. But really what we are is people who owe a huge debt of gratitude to this revolutionary shift in how can we think, how can we go about obtaining and applying knowledge. And that brings to mind a phrase, and that's where I'll go to my final slide, a phrase that is commonly attributed to Newton. It did not originate with him. It actually predates him by a long time to Bernard of Chartres, but exemplified here by particularly these lancet windows under the north transept of the Cathedral Notre Dame de Chartres in Chartres, France. And I wanted to get a better blow-up of this. Clearly I didn't. But these lancet windows here are very famous because in 4 of the 5, what is shown here are 4 of the major prophets from the Old Testament, and on their shoulders, the 4 evangelists or the writers of the Gospels. And the phrase that is exemplified by this window is that we can see farther because we stand on the shoulders, or sit on the shoulders of giants. And I believe that that is absolutely true. We can do the impressive things that we're capable of doing and discovering and developing now because of the foundation laid by these individuals of that revolution in science, the 1700s. So that is actually my last slide. I finally stopped talking, but thank you.